Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about geometric series. We'll talk about infinite and finite geometric series. We'll talk about convergence, how you know if a series converges, and then we'll give you 3 worked examples. If this is your first time to my channel, I'm so happy you're here. Thanks for coming. If you are returning, I'm thrilled that you decided to come back. If you enjoy what you see or if you learn something, please consider subscribing to my channel. Give me a thumbs up or leave a comment. What is a geometric sequence? Well, it's a sequence where each term after the first is computed by multiplying the previous term by the same non-zero constant that we call the common ratio. The common ratio can be computed by taking the second term of the sequence, a sub 2, and dividing it by the first term of the sequence, a sub 1. If we look at an example, we have an example 1, 5, 25, 125, and 625, and it keeps going on. The first term of the sequence is 1, and the second term of the sequence is 5. So if we create our common ratio, 5 over 1 gives us just 5 for our common ratio. So if you notice, 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125. So each term after the first is created by multiplying by 5 on the previous term. If we look at our second example, the first term is 9, the second term is negative 3. So when we make our ratio, we get negative 3 over 9, which is negative 1/3. And if you look back at our sequence here, 9 times negative 1/3 gives me negative 3. Negative 3 times negative 1/3 gives me positive 1. Positive 1 times negative 1/3 gives me negative 1/3. So you can see after the first term, each of these successive terms was created by taking the previous term and multiplying by negative 1/3. A geometric series is a sum of a geometric sequence. So a series in general is the sum of a sequence. So an infinite geometric series is the sum of an infinite geometric sequence. And we can write it by, we can just call it capital S, and literally just writing out each of the terms of the infinite geometric sequence and adding them together. A sub 1 is the first term, R is the common ratio. And the curious thing is here, sometimes this S exists for some values of R, and sometimes it doesn't for other values of R. So that begs the question, how do you know when the sum S of an infinite series exists and when it doesn't? Well, it all depends on the R, the common ratio. If R is between negative 1 and 1, or to say it a different way, if the absolute value of R is less than 1, then the sum exists, and you can write it by S equals a sub 1, which is the first term, divided by 1 minus R, where R is the common ratio. And if the absolute value of the common ratio is bigger than or equal to 1, then the sum doesn't exist. And by the way, if the sum exists, we say that this series converges. A little bit of math lingo for you that you might use later on. So let's find the sum of this infinite geometric series, if it exists. The first thing we need to do is we need to find the common ratio. So we find the first 2 terms. The first term is 3 over 8, and that will go in the denominator. The second term is negative 3 over 16, so that goes in the numerator. And then we just simplify. We can flip the bottom and multiply, so we have negative 3 over 16 multiplied by 8 over 3. This is looking nice because we have some simplification here. The 8 and the 16 become 1/2, and the 3's cancel. So we're left with just negative 1/2. So we've found our R. And since negative 1/2, the absolute value of negative 1/2 is less than 1, because the absolute value of negative 1/2 is just 1/2, and 1/2 is less than 1. This series converges, and we can find the sum by using our formula. So the first term in our sum is 3/8, so we have 3/8 in the top, and I don't like that 3/8. Let's put it up a little bit higher. And then we have 1 minus r, and we said r was -1/2. We do some simplification here. 1 minus 1/2, the minus and the minus become a plus. So we have 1 plus 1/2, which is 3/2. So we have 3/2 in the bottom, and we have 3/8 in the top. We can do some more simplification and flip the bottom and multiply by the top. So we have 3/8 times 2/3. And lucky for us, we have some more simplification here. Things cancel. The 3's will cancel. And the 2 will go in 4 times with the 8. And we're left with 1/4. So the sum of the infinite number of terms in this geometric sequence, or in other words, the geometric series, converges, and it converges to 1/4. Let's do another example. Find the sum of the infinite geometric series if it exists, and our terms are 3 plus 2 plus 4/3 plus 8/9 plus, and then it keeps going forever. So we first need to find our common ratio, and we find that by taking the second term divided by the first term. The second term is 2, and the first term is 3. So that was easy. No simplification needed. So we found 2/3 as our common ratio. We need to check to see if the series converges. So the absolute value of 2/3 must be less than 1. Is that true? The absolute value of 2/3 is 2/3, and 2/3 is less than 1, so it does converge. And we can find the value by using our formula. S equals the first term divided by 1 minus the common ratio. The first term again is 3, and 1 minus the common ratio. The common ratio is 2/3. 1 minus 2/3 leaves us just with 1/3, so we have 3 over 1/3. Now we can flip and multiply. So we have 3 multiplied by 3 over 1, which gives us 9. So the sum of this infinite geometric series exists, and it is 9. Let's do our final example. Find the sum of the infinite geometric series if it exists, and our sum is 3 plus 9 plus 27 plus 81, and it continues on from there. So again, our first step is to find the common ratio. We find that by taking the ratio of the second term, which is 9, divided by the first term, which is 3, and that gives us 3. So our first thought is, it doesn't converge. Well, let's check. The absolute value of 3, is that less than 1? The absolute value of 3 is 3. Is 3 less than 1? It's not. So the conditions haven't been met, and we can't use this formula for the sum. So all we say is the sum does not exist. That's what D&E stands for, does not exist. Well, I hope you enjoyed the video. Thanks for watching.